All right, welcome to our next part, ACLs. We're going to do IPv4 ACLs, where we're going to create a standard ACL, extended ACL, named ACL. We're going to apply them to different interfaces, including showing you how to secure your VTY lines as well. So let's get started. Okay. In the previous chapter, we discussed what an ACL was. We went over some basic rules for ACLs, where to apply them, direction-wise, and um, if they're standard or if it's going to be extended. Um, what's important to understand is that when we're working with ACLs, that all of our ACLs should be planned out. Uh, it is especially true for ACLs that are requiring multiple access control entries. Make sure you've got basically all your ducks in a row. So when we plan them out, we want to make sure that an easy way to do it really is to use a text editor, write out the specifics of the policy to be implemented, not just typing out your ACL into a text editor, but even just your pseudocode, just plain English, what I want this ACL to do. And you could actually use those in your remarks later on when you're actually creating your ACL. So when someone else is looking at your configs, they know what you're doing. Add the iOS configuration commands to accomplish those tasks. Include remarks. Copy and paste commands onto your device. And then, by all means, test your ACLs thoroughly before you apply them to a live network. Because it is all too common that a bad ACL brings down a network and you don't know why. Especially if you're working remotely. I've done it, guilty of it. Create an ACL on a network remotely, thinking it's going to work perfectly, and then like 10 minutes later, I start getting phone calls and text messages, people complaining that the network is now down. So you want to always look out for those particular items. Let's look at a standard numbered ACL. Okay, remember, if you remember correctly, that a standard access control list goes from 1 to 99. They can also be 1300 to 1399. When we go to 100 on up, those numbers, those are extended ACLs. But now we're just going to look at a standard ACL. So 1 to 99 is what you're typically going to do. They're simple. We have a deny statement. We have a permit statement. We get a remark statement and then the text following it. When you put a remark in the front, it's optional. You don't have to have it, but when you put it up there, it tells the incoming technician or even yourself, what the ACL was for. You're going to find that you've had an ACL running on a system for 5 years, and then you come back to service that network when something goes wrong, and you might want to be able to, look at that router and say, oh yeah, I created this to do this, I did this to this, or the engineer who was here before me did this and did that. Source identifies the network or host address to the filter. The wildcard mask, it's an inverted subnet mask, and then logging, obviously. And then, if you remember correctly, removing an access list is just simply saying no. Okay. So if we were to take a look at the the list, what we have sitting right here, router config access list 1, okay, permitted or deny, what you want it to say, and so on. All right. Come back here. We're going to create a named ACL. We're going to use the IP access list standard to create this ACL. And then we're going to remove it. Same, okay, in this example. So here we're going to create a named access list, IPv4 ACL, called no access. You'll see the prompt will change when we work on these access lists. I think I'm a little bit further ahead of myself here. Hang on. Yeah, this guy here, IP access list standard, and then you give it an access list name. So IP access list standard, no access list. All right. Um, Here we just hit, as you can see, they just hit the question mark, because then you get a listing of all the options that you can type in next. And you can see here the three highlighted items here are configured uh, uh, for the standard number named ACL. So unlike a numbered ACL method, there is no need to repeat the initial IP access list command for each access control list entry when we create these. So after the ACL is configured, then you have to link it to the interface. Remember, we use the access group command to apply it. Okay, so if the access list was access list 10, then it's going to be access group 10. Easy enough, right? To remove it, okay, to move an ACL from a router, you can just use the no access list. If you do a no access list and you didn't do a no access group, the access list, whether it's there or not, would still be applied to the router or the router's interface. So it's you should get in the habit of removing both. Okay. So if we take a look at a typical example, a numbered standard example, okay, access list 10. Okay, put a remark in there that the access list entry is set to permit only the host 192.168.10.10 to the internet. That's the remark. Then we say access list 10 again, permit host 192.168.10.10. Okay? That's it. That's the full ACL. Now, some people will say, well, why would I bother doing an extended ACL if it's so easy just to do a standard? Because this is a blanket ACL. It covers just pretty much this host is allowed to, period. It's allowed to use the interface. Right? Now, the thing about this one here, if you're paying attention, on this one here, IP access list 10 permit 192.168.10.10, so the 10 network is allowed to basically do whatever it wants. However, nobody else is. Only the host 10.10 can get on get on the internet. Nobody else can do anything. So it really only host on this one here. So access list 1 remark a access entry permits all hosts in LAN 2. Then it would be access list 10 permit 192.168.20.0, and then your inverted subnet mask. So you're looking for only the 192.168.20 network. All the hosts are allowed. Now, if we do a show access list, you'll see access list 10 has two entries, 10 and 20. Okay, we're saying 192.168.10.10 can do whatever the heck it wants, and the 20 network, okay, is also allowed out. And then you got to determine where do I want to put it. Okay. Now, if we remember, standard ACLs want to go as close to the destination as possible. So in this case here, the serial interface is what's leaving my network. So I will say interface serial 010, IP access group, because it's a group of lists, group of entries, 10, okay, because that's my number right here, okay, 10, okay, out. I want it going out. So I'm saying these guys are allowed out of my network. That's it. Access list has now been applied to our devices. Okay? The resulting policy of this will only permit 192.168.10.10 and all the hosts from LAN.2 to exit the serial 010 interface. All other hosts in the 10 network are not permitted out on the internet, are not permitted to leave this router. So if we were to do a show run and then just choose the section, the access list, we would actually see the access list 10, the remarks, and so on that went through it. finally, if we were to use the show IP interface command to verify that the interface has an ACL applied to it, we would then see that looking at the S010 interface, that the lines include an access list text. It doesn't list out the access list, it just says that there's one applied to the actual interface itself. That was the standard numbered ACL. The next is if we want to just create a named ACL. Named ACLs are nice because it kind of takes out the fact that you really don't even have to put a remark in. It's still an option for you, but you don't have to put the remark in unless you want to. So in this case here, if we want to assume that PC1 is allowed out to the internet, okay, to enable that policy, a named standard ACL called permit access could be applied to the S10 interface. So in this case here, I would say no access list, access list 10. Okay, so I removed the first access list. Now I'm going to do IP access list standard permit access. Now, the big difference you want to notice here is before the router looked and saw 10, the number 10, and said, oh, 1 through 99, that's standard access list. Now we're literally just going to say IP access list standard. Then we're going to say permit access. Notice that there are no spaces or punctuation in there. Okay, so it's just permit hyphen access, right? Then a remark. This access entry permits the host 192.168.10.10. Permit host 192.168.10.10. Now it's in there, okay? Now you'll notice that the command prompt is still sitting here as it is a named ACL. So now we want to apply the new named ACL outbound to the S1 interface. So here we're going to add another one, okay? So we're still in the permit host 192.168.10.10 because remember we want to let everyone from network 2 in too. So we say remark access entry permit all hosts in LAN 2. And then we write another entry permit 192.168.20.0 our inverted subnet mask and exit. So it's the same access control list, but instead of saying access list 10 every time, we can just keep on typing our commands and everything will follow down in suit. And then the application of it is pretty much the same. We go into our interface, IP access group, and instead of saying the number, we just put in the name and the direction on which we want it to go. We would then do a show access list command, and you would see the standard IP access list. And it would be, instead of saying 10, it would say permit dash access. And then you would actually see the access list listed in there. 10.10 and 20.0 with the wildcard mask. If you do a show run, you would see, and then choose it to show me the access list. So show run, then use the pipe command, which is just a shift key above the enter, right? Include the access list. You would see the outgoing common access list is not set. Outgoing list is permanent access or permit access. The inbound common access list is not set, and then the inbound access list is not set. So it's just showing you what is set and what isn't set, but you would also see that the permit is there. Right? So the next thing is there should be a standard packet tracer for us to do with this. So packet tracer file. Okay. Now, as you can see, we've got our network's all set up, already built for us. Now we're going to, it looks very similar to the one that we had in the previous. This is packet tracer 5.18. Okay. Our objective here, plan an ACL implementation, configure, apply, and verify standard ACL. Okay. The background here, standard access control lists are router configuration scripts that control whether a router permits or denies packets based on the source address. This activity focuses on defining filtering criteria configuring standard ACLs, applying ACLs to router interfaces, and verifying and testing the ACL implementation. Routers are already configured, including IP addresses, and enhanced interior gateway routing protocol. So the first thing we want to do is investigate the current network configuration. So before applying any ACLs to our network, it's important to confirm that we have full connectivity. Verify that the network has full connectivity by choosing a PC and pinging other devices on the network. We should be able to successfully ping every device on the network. Because right now, all access is permitted. So this guy is 10.10. Let's see here. This guy is 30.10. So let's go ahead and ping 30.10. Okay, and here we go. So there's ping in there. So let's see if we can ping our web server. Okay, the web server is 20.254. 20.254. Let's see if it lets us ping our web server. There we go. So we can pretty much ping whenever we want, okay? So that's what we wanted to make sure we could do, right? Next thing we want to do, okay, is evaluate the two network policies and plan our ACL implementations, okay? So these are the following network policies are implemented on R2, okay? The 192.168.11.0 network is not allowed to access the web server on 20.0. All others are permitted. So let's see here. He was 20.254. Let's see if he can. Okay, so he can right now. Okay, he's on the 11 network. Okay. Okay, so we want to restrict access from the 11 network to the web server without interfering with other traffic. An ACL must be created on R2. The access list must be applied to the outbound interface right here. Okay, so it's coming in here but going out there. Now, if we remember correctly, standard ACLs, okay, are pretty and it's on R2, so we wanted to go this direction here on R2. So standard ACLs are going to go as close to the destination as possible. So if we bring up, okay, so now we want to create an access control list that's going to deny traffic from the 11 network to the web server. So let's get ourselves into configuration mode, config T. Then I just simply want to type access 1. I want to deny 192.168. And I just want to block the 11 network, 11.0. So the subnet mask on 11.0 is 255.255.255.0. The inverted subnet mask, so if I subtract that 255.255.255.0 from 255.255.255, so 4 255s, I would end up with my inverted subnet mask like that. Okay. Now, the problem with this one right here is if you remember from the previous lesson that an access control list, whether you write it in or not, the last line is deny everything else. So right now, what we have done is we have denied all traffic, not just the 11 network, to the web server, which means we blocked internet to everybody else. So the next line we want to do would be access-list 1 permit anything else. Everybody else is allowed in. Oh, gotta learn how to type though. There we go. So now if I do my show access lists, oh, you'll see that I have a standard IP access list 1 denying 192.168.11 network, this network right here, okay? And then everybody else, this guy here and this guy here, they're going to be allowed to, okay, to travel. However, now I have to apply it. If we remember, standard access lists want to go as close to the destination as possible. This web server right here is my destination. So I want to apply my access control list to this interface right here. So if you remember correctly, we want to go to the interface of that interface right there. So let's do, that would be, it looks like an Ethernet interface. Let's see which one it is. Okay. And that would be my G00 interface. Okay. So we're going to hop on here. We're going to go to the interface, G0/0 interface. And then the command is not access-list, but access-group. Then you put the number, so we're doing access list 1. So it's going to be access group 1. The direction on the router, remember you want to place yourself in the router and then determine if you're in the router, where do you want to stop it. So I want to stop traffic from going out of the G00 interface to the web server. So I'm going to say outbound. Next thing we want to do is create an ACL using number 1 on R3. When a statement denies access to the 30 subnet, okay, which is right here, from PC1, which is on the 10.0 network. But I only want to deny PC1, okay? But in this case here, they're actually going to deny the entire subnet. So let's go ahead and do that. Close out of that. Let's go to R3. Remember, it's a standard access control list. We want to block stuff from going here to going to this network here. So config T. We're going to do access list 1. We want to deny 192.168.10.0 network. If I wanted to deny the host, okay, then I would put the IP address of the PC itself with a subnet mask of 0.0.0.0 following it. Instead, we're going to block the whole network. With going with a 255 subnet. Remember, we just blocked all traffic, so we have to do another access list 1 and permit everybody else to come into the network. This then will also need to be applied to an interface. It's going to need to be applied to the gigabit interface right here. So this is also a 0.0. We're going to apply that outbound. oh, I'm sorry, access group 1, and we want to choose what direction. Oh, what happened? Okay, we need to get in the interface first. So interface G0/0 IP access dash group 1, and we want this to be on the outbound interface. Okay. Now we want to verify that all of that is functioning. Okay. With the 2 ACLs in place, network traffic should be restricted according to the policies that are detailed in Part 1. We're going to use the following tests to verify the ACL implementation and to make sure it all worked. Right? Okay, so the first thing we're going to do, we'll do a show run. Okay, you can see on G00 right here, we have the IP access group 1 going outbound on the 30 interface. And you can see also that our access list is written down right there that we're denying the 10 network, the entire network, from coming in. Okay. Next thing we want to do, well, just see if we can ping it. So can we ping PC3? And PC3 should be ping 192.168.30.10. As you see now, it's unreachable. And we also want to make sure that the 11 PC cannot get to the web server. Okay, as you see here, it previously could get to the web server. Now it cannot. So that is, plainly put, a nice, simple access control list. Okay. So that packet tracer has been done. Now I want to look, how did we modify an ACL? Well, if we remember earlier when we talked about modifying an ACL, I did tell you that you could do you could modify an ACL through, I guess the next one we could do here, guys, we could do a named ACL. Let's do the named ACLs next. Hang tight. All right, so here we are. Let's go do our named ACLs. Let's get over to. Okay, so what we want to do now is we want to create a named ACL. We're going to figure in and apply the named standard ACL, and we're going to verify its implementation. Okay. The background in this scenario here is that the senior network admin has asked us to create a standard named ACL to prevent access to the file server, which is right here. The file server contains the data for the web applications. Only the web manager, workstation, PC1, and the web server need access to the file server. All their traffic to the file server should then be denied. Okay. So the first thing we want to do is verify connectivity before the ACL is configured. Okay, so this guy is supposed to have access to the file server, right? But then this guy would not. Okay. So we'll open up his command prompt. And he needs to have access to the file server, and the file server's address is 200.1. So we're going to ping. Okay, as you can see, he can get to it. Okay. And PC2, might as well check him while we're here. Okay, so everybody's got access to the file server, and that's what we want to deny, right? Right. So all that being said, now we're going to go to R1, and we're going to create an access control list. Okay. IP access dash list, just the same as you started the other ones. The difference is now instead of us saying 1 or 2 or 3 or 10, we're going to say, we're going to determine that 1, it's a standard ACL, and we're going to call it file. Now you notice there's no spaces, server restrictions. You'll notice my command prompt, or my prompt, has changed from a config to config standard and named ACL and ACL. We want to permit the host 192.168.20.4. What I love about named ACL, I don't have to type access list again. I just say permit host 192.168.100.100, and then everybody else, deny any. Now, the question is, did I need to type deny any? No, I did not. Because deny any is explicitly implied at the end of all. You didn't have to type it, but we did, and it'll still work just fine. Now we need to apply this to the interface, okay, of Fast Ethernet 01. Okay, that's this guy right here, FA01, going out. Okay, so remember, you're inside the router, you're going out, so we're going to deny that. So let's exit. Let's go to interface FA0/1. That's our Fast Ethernet 1, by the way. And we're going to say IP access dash group, and the name of it, file underscore server underscore restrictions, and the direction in which we want it to go, and that is out. Do a copy run start, save your configuration, choose defaults, we're good to go. Now we should be able to ping from here. Okay. What was that? His IP address was 200, right? 200.100 was this guy. Okay. And he is 100.1. Okay. And he is 20.1. So let's see what happens. We want to be able to ping 200.1. Okay. The web manager can ping. Okay. He could ping him earlier. Let's see if we can ping him now. Okay, he can ping. Because we permitted his, let's see, we permitted, based on it, we permitted 20.1. Now we permitted host 20.4 on R1. That's 20.3, so we have a problem with our ACL here. Let's see what we got here. Now there's our problem. See that? Fast Ethernet, this guy is 200.1. He's not 200.1. The gateway, he's 200.100. My bad. So, okay. Okay, so he got through. He's not allowed. He's not allowed. Oh, typo. I just got an email. Okay, so the only two hosts that are allowed is the web server is allowed to talk to the file server, because that's where he gets his information, and the web manager is allowed to talk to the file server. And there we just did the packet tracer for that. Easy, right? Right? Now, the methods for modifying an ACL are very easy. Okay, there's two different ways we can really do it. We can do it using sequence numbers, or we can just do it in a text editor. Sometimes doing it in a text editor is quite possibly the easiest way to do it, because then we can just remove the old ACL and then dump in the new ACL using a copy and paste method. The other method would be to do basically use a named ACL and get the sequence numbers in there. So ACLs themselves, you can have multiple ACEs. You can have them like a whole sheet long. I've seen them, and you create them in a text editor, and allows you to plan the required ACE, the entries, and then create the ACL, and then paste them into the router interface. It also makes it easier for you to edit the ACL. What I also like about doing my ACLs that way is it kind of makes it look like pseudocode, so I can review my work over and over and make sure it's right before I go and dump it in the router and then knock out a network. So an example would be like ACL1 entered incorrectly. So we, instead of saying 192.168.10.10, they made a mistake and they said 19.168.10.10. Okay. So in this case here, um, they didn't really block 192.168.10.10 from going anywhere, because they're permitting the entire 10 network. So in this case here, you'd have to remove the access list. So you say no access list 1. Then you go in and you have to say and rewrite the ACL again. Now, if you've got a 2-line ACL, it's no big deal. But to do it to do it on an ACL that's got 30, 40 lines, it'd be a real headache. So to correct the error, you can copy the ACL from the running config, paste it into a text editor, make the necessary changes, remove the previous ACL by doing no, and then pasting the other one back in. To do the sequence number method, okay, an ACL can be deleted or added using the ACL sequence numbers. Sequence numbers are automatically assigned when the access control entries are entered. Now these numbers are listed in the show access list command. The show running config does not display the sequence number, just the show access list does. So in the previous example, they had a typo in there, and it was 19.168.10.10 as opposed to 192.168.10.10. So if we use the access list standard command to edit an ACL, statements cannot be overwritten using the same sequence number as an existing statement. Therefore, the current statement will have to be deleted, okay, with the no 10 command. Then the correct entry would have to be added using the sequence number 10. And then you can verify the changes using the show access list. So in this case here, as you can see, right, we did the IP access list standard 1 command, okay, and then it came up, okay, it's still, and it made it, it's a named ACL. We wrote the word standard there. It's a named ACL called 1, okay. We did no, okay, 10, so we took out the first line, 10, right there, okay, and then we said end, okay. Then we had to go in and do a show access list, and then says deny, we did deny host 192.168.10.10, and you'll see we deleted line 10, then we had to add line 10 back into it, and then this was just one way to do it. Basically, you turned it into a named ACL by doing that. If you take a look at your command prompt or at your prompt, that you can see how you did that. Okay. Modifying it so, and it's the exact same way to do it when we do a named ACL. Okay, it's really no different. Named ACLs can also use sequence numbers to delete and add entries. In this example, an entry is added, deny host 192.168.10.11. So in this example, we have the no access list ACL 192 denying 192.168.10.10. We're permitting the 10.0 entire network in. Okay. Now we're going to come back in, okay, and we're going to say IP access list standard no access. Takes us back into the configuration mode of the no access list named ACL. Now, okay, so in between 10 and 20, we're going to say 15. Deny 192.168.10.5. End. Okay. So now when we go back in and we just show our access list, you can see, okay, you can see that we now have 192.168.10.5, 192.168.10.10. Okay. Now you'll see that they're appearing out of order. Okay. They appear out of order, but the router will process those commands in the appropriate order by going from low first. Okay. So you might expect the order of statements in the output to reflect the order in which they were entered. However, the iOS puts host statements in an order using a special hashing function. The resulting order optimizes the search for a host ACL entry, and then it searches for range statements. Please note, though, that the hashing function is only applied to host statements in an IPv4 standard access list. The details of the hashing function are beyond what we need to talk about here today. Okay. If we look at ACL statistics, okay, you'll notice that the ACL statistics command, or the show access list command, shows you how many times an access list entry has hit a match. So you'll see here we denied the 10.10 20 times. We permitted the 10 network 64 times. Okay. It gives us the ability to track how many times maybe 10 was trying to do something in the network they shouldn't be doing. And if you want to do it on a particular period, you can just choose, you can choose to clear the access counters, the access list counters command to clear those statistics, and it will start over again. So you'll notice in this case here, since the last time we had cleared it, we had 20 matches at 64. We chose to clear it, went back in and showed it 10, and the 10 network have not tried to get in since. Okay. There is another packet tracer for you guys to do. I'm not going to do this one for you. I'm going to leave that one in place for those of you who are taking the class to go ahead and do that packet tracer. It'll be in the list for you. Okay. Next thing you want to do is I talked to you guys about um, uh, setting up um, or applying your your ACLs to your router ports, your outgoing, your egress to your ingress ports. But we can also apply them to our VTY ports. So I could block Telnet. I could put an access control list on Telnet. I can put an access control list on a on an SSH. Uh, why would I want to do this? Well, I might want to say uh, only this user is allowed to SSH in. Okay. How do I do it? Instead of saying access group, okay, we're just going to change it and say access class. Okay. So the ACLs typically filter incoming or outgoing traffic on an interface. However, it can be used for remote administrative access on our VTY lines. So it just use the following two steps to secure remote administration access. Create an ACL to identify which administrative hosts should be allowed to have remote access, and then apply the ACL to the incoming traffic on the VTY line. So instead of going to interface FA0/1, we would say config. We would go to the configuration of say Cont 0 or VTY 0/4. So in this case here, as you can see, we're gonna create the access list. All right, username, admin, secret, and class. So what we've done is we're creating a local database. Okay, the local database is a username and password set that we keep on our router on the device itself that we typically would use for Telnet or SSH. So when you want to log into a Telnet session or an SSH session, um, you would say login local when you set it up, and then you're telling it, I want you to log in, but you have to use a username and password that are stored locally on this device. Right? So now we're going to say IP access list standard admin host. So now we're creating a standard access list. It's a named ACL called admin host. We're going to say remark. Remark is optional, but at least it tells you what you want to do. So I want to secure the incoming lines, and I want to permit only the host 192.168.10.10, and everybody else is denied. So only that one workstation is allowed to SSH or Telnet into this device. And I'm back to config. I say line VTY 0/4, login local, transport input Telnet. And then we're still in that line. I'm going to say access class. Okay, so that means instead of saying access group, like we did with the ACL on a standard interface, we say access-class, the name of the ACL admin host, and anything coming in to that will be applied. Okay, after an ACL to restrict access to the VTY is configured, then you want to verify it and make sure it works. To verify the statistics, issue the ACL list command. Okay. You'll notice in this one here, it tells you that the admin got in twice, and there were two others who tried to VTY or Telnet into the device, but we had locked them out. Next thing we want to look at is configuring extended ACLs. They give us more control over the packets coming in and out. Remember, before we could only look at the source addresses. Now I can go source, destination, and I can actually do TCP and UDP packets. I can go all the way up to layer 4, the transport layer. Okay, we have two kinds just like before, we have a numbered ACL and a standard ACL. Numbered ACLs are going to go from 100 to 199. They can filter the internet protocols. Use your help command whenever you can to get additional help. Selecting your protocols, okay? Sometimes you can do a protocol by name, sometimes you have to do it by number, okay? Like the standard ACLs, okay? You can use, you would have your access list number, you have a permit or deny statement. You put a remark in there, you tell what protocol and what source you, and the source, and then your destination address. You can use the destination wildcard also. We also put what's called an operator in there. So if you can in that case here, in this example, you've got your access list 100. We're going to permit the TCP protocol, any source to any destination, okay, equal, that's my operator, to www. Now, not that which is, if you know your port numbers, that's port 80. Now, not all of our port numbers have a variable that we can use, or a port number as a name that we can use. So for you notice here, these are the ones that we can use. BGP, which is 179, the CMD, okay, daytime. Okay, you can use some of these, but not all of them have one. Now, in this on the lower one here, we're going to configure the port number, okay, when you don't have a specific name, okay. So SSH does not have a name that goes with it. HTTPS, okay, it's not the same as www. So in that case there, we would have to use the actual port number. So in this case, access list 100 permit TCP, any source to any destination equal to 443, which is HTTPS, or 22, which is SSH. Right? Here, if when we set it up, we're going to apply it. Still, it's no different. Okay, we're going to say IP access dash group, and then the access list number that we created. So that we create an access list called 110 to permit the network 10 to do web and the network 10 to do HTTPS. Now with that access list, we're denying FTP, we're denying mail, we're denying everything else. But we're allowing web and HTTPS. We're going to go to our interface, G000. We're going to say access-group 110 and then in. Now remember, when we do an extended ACL, we want to place that as close to the source as possible. So as all this filtering over here isn't going across our network. If you can reduce the amount of traffic going across your network, all the better. Okay? The reason we do these ACLs, it really becomes our first firewall that we have in place. Okay? Now, TCP can also perform basic stateful firewall services using the TCP established keyword. The keyword enables inside traffic to exit the inside private network and permits the returning reply traffic to enter the inside private network. So, as you can see here. Now, however, TCP traffic generated by an outside host and attempting to communicate with an inside host would then be denied. The established keyword can be used to permit only the return HTTP traffic from requested websites while denying all other traffic. So in the topology, the design for the example that shows the ACL 110, which was previously configured, it'll filter traffic from the inside network, okay, and ACL 120 using the established keyword will filter traffic coming into the inside private network from the outside network. So 110 was permit 192.10 to do www and 443, right? 120, okay, is permitting TCP any 192.168.10.0 in all networks. So it's allowing it to come back, okay, because we use the established keyword. It's allowing our traffic to, so it's allowing a bidirectional communication there. So if we go back one real quick, we can see that the permit secure HTTPS counters, okay, for 443, okay, in the ACL 110, in return establishes counters in the ACL, okay, the 120 would also increase, okay, because we're allowing it to go both directions here. The established parameter allows only responses to traffic that originated from the 10 network to return to that network. Specifically, a match occurs if the returning TCP segment has the acknowledgement or the reset flag bit set. It'll indicate that the packet belongs to an existing connection. Without the established parameter in the ACL statement, the client could send traffic to the web server, but they would not receive traffic from the web server. That makes sense? Hope so. Okay. Syntax, naming an ACL makes it easier to understand its function. So to create a named extended ACL, use the IP access list extended command. In this example, a named extended ACL called no FTP access is created, and the prompt would change to a name instead of a config std NA or standard NACL, it changes to an extended ACL. Now we're going to create two different ACLs here. We're going to create one called surfing and one called browsing. Okay, the surfing one will permit inside HTTP traffic and HTTPS traffic to exit to the internet. The browsing one will only permit returning web traffic to the inside host, while all other traffic exiting the R1 will be denied. So let's see how that works out. So, taking a look at this, okay, the example shows the configuration for the inbound surfing ACL and the outbound browsing ACL. The surfing ACL permits the HTTP and HTTPS traffic from the inside users to exit G001, which is connecting us to the internet. The web traffic returning from the internet is permitted back to the inside private network by the browsing ACL. The inside hosts have been accessing the secure web resources from the internet. So if you do a show access list command, it'll verify your ACL statement. And notice that the permit secure HTTPS counter for 443 in the surfing ACL, and then look at the return counters for the browsing ACL. Okay? Because as you see up here, okay, in our browsing, if you take a look, permit TCP any 192.10.0, okay, it's the exact same one as this guy up here, right? The big difference is, okay, one, okay, we didn't say that it was equal to anything, right? We said established. We've already made these two connections, correct? We've established a web connection or a secure web connection. We've established it. So what we're saying is, okay, that this guy here, we're saying if these have been created, then they're allowed to come back. Notice, okay, that on this guy here, we have 124 matches, okay, plus we have our traffic from both of these actually coming back. So notice also that on our interface G00, okay, where we're surfing, okay, with in and then coming back out, okay, on the same interface is our 120, okay, which is our browsing one, and that's our established connection there. Simply put, show access list command, verify the ACL statistics. Notice that the permit secure HTTPS counter in the surfing ACL and the return established counters have increased, and those are those right there. To edit these, okay, it works the same. And the nice thing about it is it's already an AC. It's already going to be a it's already a named ACL. So all we got to do once we get into named ACL is to start typing our new sequence lines. So we get into IP access list, extended surfing. Okay, you can remove a line and then re-add it, or you can edit by doing a 5 or a 15. Okay, so in this case here, they removed 10, okay, and then they added 192.168.10 equal to www. Okay. So in the browsing one, they made it established, and surfing is this one here. Okay. In this case here, we're going to two named ACLs are going to be created. Okay. Permit PC1 to allow PC1 TCP access to the internet and deny all their hosts on the private networks. And then the other one is going to be reply PC1, and it'll only allow traffic to PC1 and implicitly deny everything else. So this is just an example for us so we can get the hang of doing this. Okay, this is a bit longer of an ACL. So me personally, I would have probably have done this one in Notepad first. Okay, but IP access list extended. Okay, so we don't have to put a number in. Give it a name. You'll see there's no spaces or periods. Okay, and they also, one of the rules is that you don't have to do it this way, but it's just because it makes it pop. Put it all in capital letters. And we're going to permit, and this is all going to be permit TCP host. Okay, or in this case here, yeah, TCP host, and then the host is 10.10. It can do FTP. It can do both 2021 for FTP. It can do SSH. It's going to Telnet. It's going to do DNS. It's going to do web, and it's going to do HTTPS. And everything else on the 10 network gets denied. Then I'm going to say IP access list. Okay, rather than type it all back out again, I'm going to say anything that the 10.10 node has requested under those particular ports, I'm going to allow it to come back in. So I'm going to say remark, okay, first it's going to be IP access list extended reply dash PC1. Then this is going to permit returning traffic back in. So any of my established connections are going to be allowed to communicate. If it wasn't a previous established connection, then it's not allowed to talk back. That also means that nodes on the outside who I didn't establish a connection with, they can't talk to 10. Okay, so permit TCP any host 192.168.10.10 established. Right, then apply it. Interface G000 IP access group permit -PC1 in and reply PC out. Verify that it's in there, show IP interface. You'll see that the outgoing access list is permitted here and in. Remember, there are two different directions, so always pay attention. Remember, put yourself inside the router. Okay. do a show access list command, and you'll actually see it. If I wanted to add something in here, I could do a 5, 15, 12, whatever's in between there. Okay. Do show running config. It'll show your access control list, but you'll notice when we do a show running config, it doesn't have them as 10, 20, 30, 40. Okay. Then there's some scenarios that I will have for those of you taking the class. I'll have those scenarios posted for you guys to do. That concludes our very long ACL tutorial for you. I hope you got some information out of it, some good stuff. And we'll see you later. Thanks.